So there can be different components of instrumentation error. You've got the inherent error in the display of whatever it is that you're reading. It may be just because it only reads to 1/10 of a digit. It may be because of the way that you have to read it. Everybody is familiar with mercury thermometers, or people who are old like me are familiar with mercury thermometers, where you have to tilt the thermometer in order to see where the silver line is. And everybody knows that you can cheat with those. You tilt it one way and ooh, you've got a fever and you can't go to school. You tilt it the other way and ooh, I don't have a fever and I can go see the movie. So it's really great that we now have digital thermometers even for measuring our body temperature. So in terms of instrumentation error, which is one of the components of imprecision, you've got the uncertainty in the display, how you read it. And that can be important. For example, if you always read your temperature probe, you know you're a certain height, you read it one way, and it's going to be really repeatable every time you read it. But if you've got different people, sometimes the other person, takes it down, looks at it, maybe they hold it for a while. Does that change the temperature? Does that change something in terms of where the actual probe is? So when you've got different people operating your instruments, the instrumentation error can be increased. You've also got the error inherent in however your instrument is measuring, the actual mechanics of what it does. I think this is a thermistor, and it could probably measure to much, much greater precision than 1 degree. But that's all that's necessary for this particular purpose. These are the thermometers that are used in the coolers with the PM2.5 filters. But you've got, for example, if you've got different sorts of thermometers, different sorts of analyzers, obviously measuring to 1 part per billion, you're going to have some uncertainty in that, depending upon how your instrument works, how the bulb, for example, in your ozone analyzer is doing that day. When you're measuring small quantities, the actual mechanics of how the instrument works can vary slightly, and there's nothing you can do about that. So try as you might, you're going to have an instrument that does the best it can, but it's going to vary slightly, even if it's measuring the exact same thing. So you've got different components of the actual instrumentation error. The differences in measuring the exact same thing one time to the next, even if you've got the same person, they hold it up the exact same way, it's going to be slightly off one time to the next, or measuring the exact same thing with what we hope are very, very almost identical instruments, in this case an ice water bath. So those are some of the components of the actual instrumentation error.